Solve the system of equations, that is 3 linear equations in 3 unknowns, x, y, and z. And in this video, we're going to do this by substitution. In other videos, I have attacked this exact same problem using matrix row reduction and elimination. But in this video, we will use substitution. So substitution involves rewriting some of these equations in the form x, y, or z equals, and then substituting that into one of the other equations. So first of all, let's rewrite one of these in that form. And I'm going to choose to rewrite this first one as z equals. And the reason I'm choosing that one is because it's the easiest to rearrange into that form right now. So 5 minus 2x minus 4y. Now I'm going to substitute that into one of my other equations. I'm going to substitute that into the second one, let's say. And to do that, I'm going to call this equation 1, this equation 2, and this equation 3. So I'm going to sub that into equation 2. When I do that, I get 3x minus 5y minus z, but z is equal to 5 minus 2x minus 4y, and that's equal to 4. So this bit here, maybe I should color code this, this bit here, 5 minus 2x minus 4y is what z was equal to there. Simplifying this a little bit, we have 3x minus 2x is 5x, minus 5y minus 4y is minus y. We've got minus 5 and then equals 4, so that's equal to 9. Now we're going to do the same thing with this one. We're going to rewrite this one as y equals 5x minus 9. And now we're going to sub that one into 3. So we have x plus y, but instead of y, we're going to write 5x minus 9. And then we have minus z, but instead of z, we're going to write 5 minus 2x minus 4, and then that's y, but instead of y, we're going to write 5x minus 9. And all of that is still equal to 6. And now we have an equation in just one variable, which is x. So expanding this out a little bit, we have x plus 5x minus 9 minus 5 plus 2x, and then minus 4 is going to be plus 4 lots of 5x minus 9. So we have x plus 5x plus 2x plus 20x. So 6x, 8x plus 20x is 28x, and minus 9, minus 5, minus 14, and then minus 36. So minus 14 minus 36 is going to give me minus 50 is equal to 6. 28x is equal to 56, and x is equal to 2. Now that x is equal to 2, we can substitute that into there to find y. We get y is equal to 5 times 2 minus 9. 10 minus 9 is 1. And now we know x and y, we substitute both of those back into z, into our original rearranged form, to get 5 minus 2 lots of 2 minus 4 lots of 1. That's 5 minus 4 is 1, minus 4 is minus 3. So our final answer is x equals 2, y equals 1, and z equals negative 3. The same values we got via elimination and via matrix row reduction. This method can be the most direct, but it's worth noting that in this particular case, it was very easy to rewrite rewrite this first equation as z equals, because it was just z. We didn't have to do any division. If this was 2z, to get to this z, we would have to divide the whole thing by 2, and you end up with a fraction quite a big fraction that you have to substitute in here. It does work, but you end up with a lot of fraction work that you have to deal with, and that's an area that's prone for easy mistakes. Also, this one worked out quite nicely because we just had the y, and the same thing could have happened if this had been 5x plus or minus 3y at this point. We would have had to divide it by 3, and we could have ended up with more fractions. So you could have ended up with fractions within fractions at this stage, which would make it a lot more complicated. It's a useful approach, but I think this one only really works nicely if you have the ability to make one of them equal without having to do any division in the first section, in the first part. Because otherwise you end up with all those fractions following through, and as I said, it is so easy to make a mistake when dealing with those.